For this problem, I'm given a singly linked list and I need to find the middle of the list. So an example is in input 1, 2, 3, 4, 5, out would be 3. In the case where there is an even amount of nodes, you must pick the second middle number. So with the case of 1, 2, 3, 4, where 2 and 3 are the numbers in the middle, oops, I said 4, but that should also be 3. You would pick 3. I'm thinking about doing this is by getting the count of the linked list, so either by using the count function, or if that's not allowed, going through it and incrementing a counter each time you get to a node that isn't null. Then dividing the counter by 2 plus 1, so in the case of like when there are 5 divided by 2, we're going to get 2 plus 1 equals 3. So we would go to the third node. 4 divided by 2 equals 2 plus 1 equals 3. Go to the third node. And then we'd go to that node and return the value. Okay. So we have our method. We're going to be returning an integer. I called it middle node. We're getting a linked list with some type of information called x. We have our count, which is equal to the count of x. If we couldn't use count, then I would loop through each one and increment a counter. Then we have the middle, which is count divided by 2. I decided instead of adding plus 1, I would start our for loop starting at 0. Has the same effect. And then we have a pointer that starts at the first node. So we would go in the example of 1, 2, 3, 4, 5. We're starting at I equals 0 and our current is here. Then we move our current is equal to current.next, and then I is incremented to 1. Then our current is equal to the next one. Our I is incremented to 2. Oh, we want this to be minus 1. And then so less than. No, less than. Because then it would stop. We are at 3, and we would return current, which is 3. Our time complexity would be n plus n over 2, because to get the count, that's time n, and to get to the middle current node, that's n over 2, and our space is constant.